Hello everybody. Very welcome. So let's see who do we have by now. We have Brian and we have Gang and Jensen and Steve. Okay, that's awesome. So let me give you the link that you all guys need, and I will share the screen for that. And that is what you need. So let me give you the bit.ly link. Give it to you on chat. Okay, that's your link. You can type it or you can click on it, and what you will see is exactly that. Now, for those people who are new, that's Advances in AI webinar, and since these advances are not slowing down, perhaps they are speeding up, that doesn't change for the last 3 years. So that's the link to that. Now, the next step is usually people, if they're new, they want to know what should they learn, what should they do, and that is that link right here. So if you open that, oh, why is that doing it? Sorry. Somehow it's some kind of replace with a link. Oh, that's mine. That's what I mean, learning path. So people often ask, what should I learn? If I click here, yes, I'll see it, but I will be nice. I will give you a copy. Put also that on the chat. Put that on the chat, so if you want to open it, you can see what to learn. Now, it works like this. If you open that, and I will eat my own dog food and I will open that too. You will see the courses. They come from all different sources, but most of them are from Learning AI, deep Learning AI. Now, how many of them there are? It's more than 100 by now. I don't have a new course today. I have other new things, but that's what that is. So if you haven't learned anything like that, and that's a big question, we will be talking about learning. So if you haven't ever learned anything here, then start from the beginning, and there is a generative AI for everyone. But after that, you will choose your own sweet poison, and you will learn whatever technology you will want, and whatever is whatever strikes your fancy, that's what you can do. I was thinking about something. So OpenAI has a series of lectures, and that series of lectures has jobs today, jobs in the age of AI. So, you need to show something, so I'll be showing you that. Okay, I'll show that. Okay, so I'm downloading a small slide deck. Okay, and the major idea that everybody, I think everybody today talks about is that we are looking at a partnership. We're looking at a partnership between humans and AI. And well, sorry to say that the sooner the humans accept it, the more successful they will be. Otherwise, we have data which says that 13% of people are already unemployed in the age of 22 to 25 in AI exposed jobs. So what do you do? At the same time, that same study, which we talked about last time, that same study says that other people are not suffering, and some other people are not suffering at all with the $100 million a year packages. But what's important is that, as Ender End said, it's that not that the programmers will be replaced by AI, it's the programmers that are using AI or partnering with AI, those will be replacing the programs that don't. Now, I'm touching on some touchy subjects, so I'm opening the chat. Okay, people like to give their links, and that's wonderful, because the more interaction we have, the better. So when you're trying to find out who will be affected, the answer is everybody in the world will be affected, at least according to the future of work in the age of AI. OpenAI is the source. That's an interesting show. I listened to it, even though nothing was new, but now I can say that nothing was new. You can only say it when you do listen to all of them. So the end result is that I don't see any way to explain it other than yes, humans are humans, AI as a AI, and the famous poem East and East and West and West, and never the two shall meet. But here they do meet. It has to be this way. So humans will have to understand what's special about them. Where are they better? So these are supposed strengths of a human. You see, you can read them. I'm not reading. It's what human is special about. And the more you work with AI, and you will be surprised, I work with some people who are not using AI. And the first step that I tell them, very obvious: start using it. Start using the AI. Okay, so we are not going to have a golden recipe how to become better in the AI, and don't try to do that. Why? One of the arguments that they mentioned in the show, that every new technology is bringing its own dangers. For example, when the car appeared, so you don't walk as much as you used to. True. I mean, that's true. You can't avoid it. You have a car, don't try to outrun the car. On the other hand, well, increase your exercise, because if you don't do that, then, you can't walk. All right, that is the very obvious advice, but you need to start to thinking. I also quote here Andrew Ng that I just told you. Okay, sorry if I lose the focus. So universities, what should they do? The universities should teach working with AI very early. And I'm sure that in a year or two, that will be obvious, of course. But right now, it's not quite. And we're offering to universities to start. Corporations, they also need to, and we have enough classes that's going on right now that people want us to come and teach them how to use AI. It can be all levels, and that's what Chad OpenAI is saying. Of course, they are saying it. They are prejudiced. They think they are right. That, what can you do? Every person thinks they are right. So, from smallest businesses of two people or one person to the largest, they all need to start to use this tool, because that is a tool that never was before. Okay, so everybody will join, everybody will gain, and that is what I wanted to again show it to you, because we started talking about this last time, but this time it was even more. Okay, now that we all kind of agree on that, and everybody welcome. What you can do, let me go back to the chat. Okay, you can say hello from Houston, Texas. That's where I happen to be. And you can all say hello from Vallejo or hello from wherever. Give your links, give your LinkedIn. Everything is okay, but we're going to do what we're going to do. That's here. So every Friday, today is September 12th, 2025, we go through interesting things that happen. I will do this. I will go in the reverse order. That's how I prepared. So I will show you what's interesting in quantum computing. Then I will show you what interesting is in LangGraph. Okay, I see now hello from San Francisco, RTP, and more from Houston. That's wonderful. Okay, so I'll start from quantum computing. Why? Why do I start from quantum computing? That is because it doesn't generate as much noise, but it has as much potential, if not more. So, a few words about quantum computing. It is using the idea of Richard Feynman, and the idea is nature can do some things that we as humans cannot, and it can also do computation in the way that our computers cannot. And what is it? Well, simply stated, I would say it's being everywhere at once. Now, philosophically, how can you be everywhere at once? That's good question, but we absolutely cannot go that way because it's too interesting. We will not be able to finish this conversation. But we all know that quantums, all those little particles, it's not even microscopic particles, it's elementary particles. They are kind of waves and kind of particles. So sometimes behave like waves, sometimes like particle, and that means they can be everywhere at the same time. They just decide on that later. With that, I can show you how that works. Annealing. So first of all, there is such a thing as quantum computing that is based on the idea of very small particles behaving like waves. And at the same time, it's not a very smart, very fast computer. No, it's doing very specific things. For example, breaking the encryption on the internet. It can do it. Give it maybe a year, two, three, four, five, depends on upon whom you ask, but it can do it because it can calculate everything at once, and it can do very specific things. One of them is that breaking the breaking the encryption. But other things are also very specific. Quantum computing can do maybe four or five, like material discovery, drug discovery. Now, the one that I'm going to show is practical. All others still have not resulted in anything that's working practically. People may disagree. That one, annealing, it does something practical. That's why I want to show that to you first. So annealing means you heat something very much and then you let it cool. That's what annealing as a word means. And the similar thing is happening. Oh, I see, Steve Wolf. How can you be in two places at once when you're not anywhere at all? That's a great question. But we continue here and we're saying that annealing. Can I? Yeah, I'll move it like that. That's the idea of annealing. So it's a very specific, even more specific, even more limited algorithm that the quantum computing can do. But if it does it, then you can do very complicated planning. Now it works for large sizes, but like 100 workers doing 100 things at the same time on the same map. That's the kind of thing it can do, and it can do it better than regular computers. That's what this is, and there is a hardware that actually implements it, and that the company who says they do it is called D-Wave. prepares that hardware for you. You could even buy it. And the reason I wanted to show you that is because that's one area where they have achieved practical results. So they have implemented it, they're achieving very fast planning. Let's say the situation changes all the time. You can think of military application where a situation changes all the time and you need to model many uh, moving targets, right? So that's what it is about. Let's go on. How does it work? So none of that is obvious. By now, AI and quantum computing share similarities. They also try to interplay that hasn't happened, but they share similarities in that it is magic. It's absolute magic. AI is absolute magic, and quantum computing, and specifically annealing, that is one algorithm that's implemented on that hardware that can do miracles. Okay, so you know that when you're trying to find the minimum of a function, which is a favorite thing is in AI, right? You're dealing with very complicated surfaces and you're trying to find the global minimum. Then the problem there is that you could just using gradient descent go to the lowest place. The problem is that you may reach a local minimum. Very likely you will reach a local minimum. How do they solve that problem in AI? Well, they have additional randomization and you don't get stuck in one specific place. In quantum annealing, they use the fact that the particles are everywhere at the same time and they can be said to go through the energy barrier. So if you can only formulate your problem in terms of quantum algorithm, we'll come to this algorithm very soon, then you can solve your problem and you can imagine in your mind that your particle, which is trying to find the minimum, it goes through the walls. Instead of just going normally on the surface, it can jump because it can be everywhere at the same time. Now, if it sounds too magical, yes, it is. What you need to do is to learn a little math. That little math is called the Hamiltonian. Hamiltonian is a formula for energy state, and you're looking for the lowest energy state. And if you can formulate your planning problem as a mathematical problem with Hamiltonian, then you got it made, and then you give it over to the quantum computer. Now, the term to remember here is QUBO, Quadratic Unconstrained Binary Optimization, which doesn't make much sense, but it's the algorithm how they solve it. And there is another way to solve it, and I'm only giving you the terms right now. It's I-Ching model. Now, I-Ching sounds like I Ching. It's not. It's not a Chinese name. It's a name of a German mathematician. In the 30s, he came up with that. All right. Well, so why was I talking about this? Is because there are lots of parallels between quantum computing and AI. So far, both ways that people are trying to use quantum computing to speed up AI learning. They are also trying to use AI for quantum computing. In the second way, they did achieve something. They can predict something rather than run it, and that works. In the first way, they haven't much. So both miracles are promising. Both miracles promise one will improve the other. It didn't quite happen, but that one you can do today. So what you do, you can go to Z-Wave site like this, Z-Wave, okay, and you can then sign up, can get an account. You will get access to virtual machine like that for free to start, and you can experiment. Can you put your problem into the terms of quantum computing? If you can, well, buy the real thing I still don't know what the price is, but first you can run it on a virtual computer. That is almost everything I wanted to show you. Now, let's go to this link because that would explain QUBO. That would explain a bit more about. I only want to show you the beginning. That is the math behind it. So it's a mathematical formulation on how you would express the optimization problem. So who has optimization problem? I do. Let's say I have many trucks going in different directions, but really many trucks, because if I have 1,000, that's nothing. Maybe 10,000 where it begins to shine. If you can formulate that problem in terms of uh, mathematics, then you can maybe solve it with quantum annealing. Okay, that's one. I covered one. Let me go to the chat and see what people say. Paul, eSing, I checked it. It's not iSing. Majority of people pronounce it eSing, and that would make sense, being that's a German word, and they wouldn't use the letter I to express the sound I. And you heard at the BU Physics that they were working on such simulations. Here, of course, pronunciation can drift. Okay, you can say it both ways. Traveling salesman problem is one of them, exactly, and that's what I wanted to hint to, that it would be traveling salesman or cutting up the map in the optimal way, cutting up the material in the optimal way. Lens also mentions that I use simulation annealing on CM3. Wow, to solve NP hard problem in graduate school. Yes. By the way, that's an important term. NP hard, computationally hard, means that you cannot solve it in a reasonable time. What's a reasonable time? That is, how many particles do we have in the universe? I think this 10 to the power of 78. Okay? And usually your argument goes like that, that if you want create a computer out of all particles in the world, you cannot build more than 10 to the power of 78. With quantum computing, that's not the logic, because you have multiple particles and they're everywhere at the same time. So theoretically, you can beat even that limit. You can beat any imaginable limit. Okay, so that is something that you guys did. Very nice, thank you. Simulated annealing doesn't guarantee global optimum. I would believe that simulated annealing doesn't, because otherwise why would we need the real hardware? But the real hardware, I think, either guarantees that to you or gives something close to the best. So that's a good question. Let's do it this way. Let us do some more research, and by the next week, we'll have to revisit every subject that we have here. Very good. Thank you very much. Next subject, LangGraph. So LangGraph is one of the agentic system. Agentic is everywhere, everything. And Andrew Ng suggested a simple solution. What is agentic? If it feels like agentic and quacks like agentic, then let's not worry. Call it agentic. Everybody will call it that anyway, especially in marketing. Okay, so what did I do? I prepared a demo, a real thing. So to do that, all you need to do is go to that lab. So let me go you where it is. Right here. Okay. And that's the lab. Okay. That's a copy of that lab. That's Agentic with LangGraph, which is one of the popular frameworks. I'm giving it to you here on chat. And that's what you can call a run. That's what I did. I do run it. When you come there, run terminal. here. When you come here, let me close it. Okay. So I'm in exactly that lab. And the first thing I need to do is let's deactivate so that I show it from the very beginning. Okay. Well, there is a how to run the very first time. I'll show you. And that's how to run the very first time. It has all the instructions, but you can also copy paste the whole thing and it installs what you need. That's how you run them the first time. But there is also how to run it every next time. And next time just says source that environment and do Jupyter Lab. Let's do that. First of all, we source that environment. And then we see that we're in the right environment. With that, we simply type Jupyter Lab. Okay, what do you do now? You open the first lab here. And that is explaining the idea. But the idea, the way I understood it, is you work with LLM, but you work with them in a loop. So you ask a question, you allow it to think, then it comes back with an answer. You rethink what it answered, you then ask again. That's called React. So React is not a framework, but rather a design pattern based on this. So let's go there. Let's look at React design pattern by Simon Willison, who is the author of an important framework, but also interesting articles on security. So we go there and we find that I especially like the beginning. So that's an idea for implementation of the React pattern. React means ask and think and ask again. And then he says a popular nightmare scenario for AI is giving it access to tools so it can make API calls and execute its own code and generally break free of the constraints of its initial environment. So if you want to write a science fiction novel, you can. And he doesn't really mean that it's nightmare. It's just a nice way to put it. What he means is that if you give AI a chance to do more on the second step and more on the third, that's how it can get rid of the initial situation. So that's React, stands for reason and act, is described in yet another paper. And all of that justifies what we said about this framework, that it does require a little learning, it does require coding, but we looked enough at that and we have already the code, so let's do that. So what we do is not agentic per se, but the idea of agentic. How do we do it? Well, here I open AI to the ChatGPT. I'm using the GPT-5, which came out recently, and I'm going to do some question answers. That's nothing new. What's interesting is that we're going to then feed that answer into our next question. So now the system prompt. You run a loop of thought, action, pause, very important, and observation. At the end of the loop, you output the answer. So that is exactly what Simon Willison explained in his paper, and what actions you are giving it. Calculate average dog weight. So you're limiting what it can do to a few operations, and you code this in the system prompt. Now, let's see what you can do with that. ABOT stands for an agent, which comes from OpenAI. Okay. And now we're going to give it our question. So based on that, based on these tools that you can use, don't just do what you are usually doing. You are AI. No, use it according to my system prompt. So my question is, how much does a toy poodle weigh? Okay, it begins thinking, coming back, and gives us its thoughts, then pauses, and then goes again. It says, I should look up an average weight of a toy poodle using the average dog weight in action because that's the action I'm allowed to use. Then it pauses. Maybe I will add something, but that formula worked. The next prompt is based on the result of the previous one. So the observation, that's the observation. And that's the result. I want to do more. What if I have two dogs? That's them. What can you do with your set of tools? So all of that illustrates how you can keep asking questions, thinking through them, action, do more, and then you add the loop. So you're doing a loop. It's like you're thinking there and you keep thinking more and more. By the way, I fixed that line. It wouldn't work in the original, but now it does. So we're ready with more questions. Okay, so it goes and does many things, finally does the calculation. That is the major idea. Now we're going to implement it. So far, we implemented it straight in the code, but what we want to do is go into the what elements do we have in LangGraph that will help us do that. Now, here I have to apologize and I have to admit imperfections. I have a rule, and the rule is very simple. Demos never work. Okay, so with that expectation, you will not be surprised if I clean it all up. Then something must happen, right? Okay, I install it, but it still doesn't find stuff. It somehow gets the wrong environment. You see, I was debugging and it didn't find the right environment. But not to be perturbed, what you can do is go in that lab, find out the README. README is here. That honestly tells you which is the original project. That's what you do for now until I fix all the rest. And then, so I'm closing what we don't need. And then you will be here. In Andrew Ng's labs, the labs will work. It's only when you try to do it the real stuff, then it doesn't. And you probably will do well to refresh.
Well, really cool human in the loop.
And that will explain to you all the details. First of all, what LangGraph components are there? Okay, let's try to see that. These are the LangGraph components. In other words, that what I showed you in the code, hard-coded, this idea, it's now in the LangGraph components. So we are going to use a specific tool, and that tool will be Tavili search. We are agent search to our agents and giving it a tool. And now we need to organize that somehow. So we define the functions that help us organize it. And now we can go into the loop. And that's already agentic at its best, where we combine multiple tools. We include the weather tool, and we allow AI to go on its own. That's what this lab does. Now, if we look at the other labs, we'll see the agentic search tools, which are smarter. What I'm interested specifically in the human in the loop. So if we go here,
There are many occasions when
okay, we want to include the human in the loop. That's the proof of the point that we want to have partnership between humans and AI, and that will work wonderful. Well, there are lots of unanswered questions. So I can suggest a few. What if the human doesn't want to learn? What if the human doesn't want to do what we expect him or her to do? Okay. And what if the AI goes berserk? There are good questions, very good questions. But even working on them is your good asset. So, how do we do this? Okay. We prepare the environment. We want the human in the loop. And that's where we will allow to do human approval to what happened. And now I understand that this agentic framework is just a perfect thing. Okay. And because we have created a framework where we can insert a human and then let them cooperate. That's what we do here. Now, my next step really should be, I should show it not here, but show it in the real environment like that. Well, that's next time. I'm already better than before, right? At least I'm not showing you just the show. I'm showing you the real thing in combination with the show. Okay, I hope it will be better next time. I'm making a pause. I'm looking at your comments in the chat. Okay, maybe that. Thank you, Steve. Maybe sometimes there were all the people. Yeah, could be anything. I'll try and try and try until I succeed. That's what I've always done so far. All right, that was wonderful. Now let me do this. There is a new, okay, going back. There is a new great thing called Kiro. If you go, well, first of all, it's so new that even AI wouldn't know right away. But if you say, I want Kiro that's coming from Amazon, then it will know what it is. It will be this one. But you won't get it. You can watch the demo or you can join the waitlist. I joined the waitlist. I was accepted. I have Kiro. I will show it to you in a second. But right now, I will stop share. I will share again, this time with the sound. So in case the demo has any interesting sounds, we will hear them. Okay? So let's do it. Watch the demo.
Hi, this is Kiro, the new Agentic IDE that works alongside you from concept to production. Let me give you a tour of some of the features of Kiro. First, we'll click on that ghost hand icon on the left-hand side. Now I'll click the Generate Steering Docs button. This will help Kiro better understand the application when we prompt it later. Now that the docs are created, you can find them in the Kiro steering folder. These files describe a serverless full-stack web app that we're using with a Next.js and a AWS backend. Let me show you one of our most powerful features, Spec. I'll ask Kiro to add a new way to sign into our app using Google. Kiro is going to help us code this up and give us a step-by-step process so it gets it right. The Spec feature generated this requirements document as its first step in helping us create this feature. It has user stories and acceptance criteria. I'll review it and add another criteria to improve the way sign-out is handled. For this next step, Kiro generated this in-depth design document. It includes a mermaid diagram, infrastructure changes, and configurations. This looks good to me. We'll continue on. Finally, we're presented with a task list. Kiro has broken up this feature into smaller parts that it can complete one by one. I really like this feature because I can interactively have Kiro complete a task at a time, and I can verify or make changes if needed afterwards. I'm going to have it start on these tasks. I'll queue a few, and I'll check it along the way. This will take a short while. While it works, I'll set everything up inside the Google Cloud Console outside this video. It's been a few moments. We're now in task 5, and it's updating the Prisma update to include the Google account. Great, it's now completed all the tasks. I did a few updates during each task to make sure everything was working, and now let's take a look at the output. Here's the application. It has this new sign in with Google button. All the backend and infrastructure has been completed because of Kiro. If we test the login, it looks good. This next feature is really helpful. It's called agent hooks. To get started, I'll click the little ghost icon on the left-hand side, and then I'll click the little plus arrow next to agent hooks. I want this hook to create tests anytime I save a component if they're not already there. So I'm going to describe this in the prompt. On file save, add a few basic tests if not already created for each component. And then I'm going to click this enter icon. Kiro is going to create this hook for me, and it'll be listening in that background for that file save. So I'm going to see it now inside the .kiro folder, this new hooks, and then I can give it a try. So I'm going to go into one of my components, and I'm just going to add a quick comment to it and make sure it works. So I'm going to type in test comment here, and then I'm going to open up the task list, and you can see it running already in the background here, and it'll start creating the tests. This will just take a few moments. Here's the new test, the Google sign-in button test. I'll look through it, created several of them, looks really good. Kiro does more than just development with specs and agent hooks. We also support native MCP and vibe coding. With Kiro, you can go from concept to production and beyond. Go ahead and give it a try. It's free during preview.
Okay, that's wonderful, right? Let's try to do it. So first of all, I prepared a little bit of a description of what it is going to do. I'm closing all the unneeded things here. Okay, so what it is supposed to do is this. Okay, the idea is that it's for, I would say, enterprise developers. And it does more than just only coding. It is an attempt of Amazon to compete, to keep competing there. 33% of the market. Uh, Microsoft is 20, Google is 14. So it's been stable for a long time, and that's the new thingy. Okay, so it does more than just code. It gives you the specs, it writes the specs, gives you the complete workflow. You add the hooks so that they listen to what's going on. You also test it. So that's what it should happen. Now, let's do it. So for that, let's open. Now, before I open, I will exit, okay? Starting is easy on the command line, so let's do that. Let's come here, close all the rest. But there will be a certain point where I will really want your help. So I created the project. If I save anything, it will be in Kiro projects, first sample. Now I say Kiro, okay? Well, so I was trying to say something on the terminal. No, it didn't work. That is the Kiro, and that's why I'm supposed to start talking, okay? But I couldn't. Honestly, I'm really, I'm not joking. I'm waiting for your help because here I don't have any project. I want to start doing something. So I'm saying create a sample app, but it looked so good in the demo, I couldn't do it in the real life. So I'm pausing, okay, and I'm waiting on the chat. What should I do next, guys? Help me. If not, of course, I'll show it next time. But this time we have a chance to really make it a seminar. We're all working together. Here I am, open the chat. And so you're saying Kiro.dev? Yeah, we need to learn more about VS Code, but VS Code is kind of easy. So, Paul, you're saying I should take app, create that. Yeah, project starts in the folder. Okay, so I copied what Paul told me to do. Now, where do I put it? Do I say here, right? We don't need that. And what? Nothing, right? So here I am. Maybe a new project. And of course, I could do this. I can say, Kira, kind of listen to me, right? That's what you're saying. No. Okay, add spec from multiple auction methods. Second price, Dutch. That's great, etc. Paul, you want my mouse? Oh, it's a webinar, maybe no mouse. Hey, at the risk, very real, of making myself a fool, I would call it's a complete failure. I got the tool, wonderful. I know what it's supposed to do. I saw the demo. Nothing works, right? Okay, I think I achieved all goals other than making it run. All right, very good. Okay, so we have what to do. Next time we'll need to repeat all of that, but this time, next time, we'll do it right. So I'm making a copy of that. Okay. So what I'm saying is that that is the plan. Draw IIO. Very interesting. Okay, great. All right, that was useful. At least we got 50%, 80%, whatever we got. All right, everybody, thank you very, very much. I wish you all the best, a great weekend, and a great year ahead. Thank you. Goodbye.